Hi everyone, this is Mohammed from megaprogrammers.com, and in this video we're going to be talking about using numbers in C#. We talked about data types in Introduction to C# Data Types video, but today we're going to create some variables using those data types and see how they react when we assign a value that doesn't match the width or the type of the variable. I took the liberty to create a new project in Visual Studio and I called it using numbers. So let's take a look at our first data type, which is byte. As we saw in declaring variables video, in order to create a variable, we need to start by the data type. So in this case, it's byte. And then we need to give it a name. And I'm going to go with my byte with an uppercase B as recommended by C#. As we know by now, the byte is an unsigned integer, which means that it can only store positive values along with 0, and it's 8 bits in width. So that gives us limited amount of numbers to store in it. And the range is between 0 and 255. The next step is the assignment operator, or the equal sign. And then the value itself, and we're going to go with 128, and don't forget your semicolon after each C# statement. Let's output this value to the console window. So we will type console.writeLine my byte. And in order to get the command prompt to stick around, we're going to use console.readLine, so the command prompt would wait for our input before closing. So console.readLine. And let's go ahead and click on the start button, and as you can see, 128. Just for the sake of this demonstration, let's try to assign a value which is out of the range of values that we can assign to the byte. So we know that the maximum value is 255, but let's go ahead with 300. As you can see, the compiler will start complaining as it is not considering it a byte anymore. If you hover over the error, it will tell you that it represents a 32-bit integer, which is the type int, and it cannot be converted to byte. So let's get it back to 128 and then move on to the next data type. The second data type is going to be the SBite or the signed byte, which is similar to byte in every way, but of course it's a signed byte, and that means it can store negative values as well as positive values, and the range of values will be between -128 and 127. It's still 8 bits in width or size, so that means again the range is going to be so limited. So let's go ahead and start with the name. So SBite, my SBite equals, and let's just give it the value 12, and let's output that to the console. So I'm just gonna, wrong button, I'm just gonna copy that line here, and then paste it, and then just change that to my SBite, and hit start. And as you can see, 12, again, no problem. The next data type is the most common data type that you'll see, which is the int. It's a signed integer, so again, that means negative and positive values. Its width is 32 bits, and that means it can store really large values into it. So let's go with 32,000. So I'm going to create int my int equals 32,000. And let's go ahead and paste that line. Just change that to my int. Click start. And as you can see, 32,000, no problem. The next data type though is going to be an integer as well, but it's going to be the uint. And that means it's unsigned value. And again, 0 along with positive values. It's still 32 bits. So I'm going to go ahead and create a uint. My uint equals, let's go with 20,000. And then let's go ahead and paste our console.writeLine and my uint. As we can see, 20,000, no problem at all. The next data types, which are integer data types as well, they are short and ushort. And of course, by now you know the difference between the signed and unsigned. But I'll be repeating it one more time, as when I started learning programming, they were a little bit confusing, so forgive me for repeating this point a lot. So again, signed is negative values as well as positive values. Unsigned means can store 0 along with positive values. So we have short and ushort. So let's start with the short and give it the name my short. Give it the value of minus 12,000. And again, my console statement, my short. And then go with my ushort. So ushort, my ushort equals 12,000. My ushort. Click start. And as you can see, no problem. So the short and ushort are 16 bits in width, and that means they will store less value than the int and the uint. Alright, let's stop here for a second as I wanted to go further into the video before mentioning this point. So why there are many data types just for the integer? Why is there 8 bits for the byte, 16 bits for the short, and then 32 bits for the int, and then 64 bits for the long, which we'll be taking a look at later in this video? Why there is many data types as well as sizes just for one thing, which is the integer. So the reasons behind this is that before, computers were not advanced like the ones we have today. The memory was so limited, and the programmers had to be careful with what data type they are going to use. So they wouldn't waste memory on a value, let's say of 3, and the programmer knows that this value will not change, or even when it changes, it will not exceed the 127, for example. So there is no point in storing that value in a type int, for example, because when you declare a variable, there's 32 bits in the memory that is going to be taken, whether you use it all or not. The second reason is the floating point numbers and integer numbers are stored differently in the computer. The next data type, you guessed it, it's the long and the ulong. So let's go ahead and create two variables. So first one is going to be the type long, my long, and then u long, my u long. Let's just fix that spacing. The only reason the spaces are like that is because it's considering that as a one command. So let's go ahead and give the long minus 32 million. And then I need the equals here. And let's go ahead and give the u long 32 million. I think that's 32 million. 1, 2, 3, yeah. And let's go ahead with our console. My long. And let's just give it a space here. And then another console. My u long. Let's go ahead and click start. And as you can see, no problem. They output it to the command prompt. Now let's go ahead with the floating point numbers and see some examples on the data. We can use float, double, or decimal. The width of the double is 64 bits, and all floating point data types can store negative values as well as positive values. There is no signed and unsigned for those data types. So I'm going to go ahead double my double and give it 3.3 and just output it to wrong one. So let's just go ahead and copy that one, paste it, my double, And let's go ahead and click start. As you can see, 3.3 on the command prompt, no problem. The next data type is going to be float. So float is 32 bits in width or size, so it can store smaller values than the double according, of course, to the size. 64 bits for the double, 32 bits for the float. So float, my float equals 3.5. Wait a minute, there is a problem. The compiler is complaining. So let's go ahead and hover. And as you can see, it represents a double precision floating point number. What does that mean? So you'll need to specify when it comes to the floating point numbers that the value assigned to them, you'll need to add the letter F to let it know that it's a floating point number or a float of a type float. So you'll need to assign the letter F to let that float or my float of the type float to know that it's float, because all numbers are considered double. So if we took the F off, and as you can see, literal type double cannot be implicitly converted to the type float, use F suffix to create the literal data type. So basically the 3.5 on its own is a double. If you add the F to it, it's a float. All right, let's go ahead and output that to our console. As you can see, 3.5, no problem. The last data type in this video will be the decimal. The decimal is 128-bit in size or width. Decimal data type provides the greatest number of digits. It supports up to 29 digits, and it's used for high precision value. The decimal value type is appropriate for financial calculations requiring large numbers of significant integral and fractional digits with no round-offs errors. So with the decimal, you will not get any round-offs. So let's go ahead and create one of those. So decimal, my decimal equals, and I'm just going to be using a small number compared to what it can actually store. I'm just going to go ahead with 3.8. And again, the same problem as with the float. It is a double, so it needs to be converted to a decimal, or we need to tell, no, it is actually a decimal by adding the letter M at the end of it. And then we can output it to our command prompt, my decimal, double. I hope I spelled it correctly. Let's go ahead and click start. As you can see, 3.8. Again, when the compiler was complaining, it was complaining because the value is double and it was trying to convert it into decimal. And again, the solution was simple. Add the letter F for the float, add the letter M for the decimal. So the last trick in this video that I'm going to be showing you is how you can determine the maximum value of a data type. So let's say I would like to know what is the maximum value the integer can store. That can be done by console dot writeLine and int dot max value. The max value here is called a constant, and we will be taking a look at constants at a later video. But let's go ahead and put our semicolon and hit start. And as you can see, this is the maximum number that we can store in the integer. If you would like, of course, to let's go with anything. So let's go with byte, as it is the smaller one. And as you can see, 255. So at the end of this video, I'm going to be giving you a little challenge. It's going to be an easy one though, so no worries. What is the constant to determine the minimum value of the data type? Thank you very much for watching, and happy programming.